Okay, so the second practice problem, again, you should always draw a picture if you can. So we're optimizing a straight piece of wire that's 8 feet long. It is then bent into the shape of an L. What is the shortest possible distance between the ends? Okay, so we've got a straight piece of wire that we're going to bend into an L. So it's going to look like this. They want to know what is the shortest possible distance between the ends. Okay, so between the ends means basically they want this distance right here. Okay, to make that short. Okay, the shortest it could be. So basically we've got to set up our primary and our secondary equations. Okay, now since I'm trying to optimize this side, I'm going to be using Pythagorean theorem. Okay, so let's say this is side A, this is side B. So my primary equation is going to be c equals the square root of a squared plus b squared. Okay, that's my primary. Okay, because basically when you shape this into an L, you get this kind of triangle here. Okay, that's my primary. What is my secondary? What is my limiting factor? Well, it's the amount of wire I have. Okay, so my secondary is basically like the perimeter, where the 8 feet has to be equal to A plus B. This is my secondary. You can almost think of it as like perimeter, but just for the two sides, since basically that's the dotted line there is an imaginary distance. It's not an actual wire that we're going to be using. Okay, so that's going to allow us, in this case, to get our primary in terms of one variable. So you can solve for either one you want. It doesn't really make a difference if you want to solve this for A or B, but I'm going to solve it for B. So B equals 8 minus A. So again, we're going to use our primary equation and we're going to take the secondary, plug it in. So that means side C is going to be the square root of A squared plus 8 minus A squared. Okay, so now I have my primary in terms of one equation. Okay, I'm going to simplify first. Okay, before I go and take the derivative of this, I'm going to take this a squared plus and take 8 minus a squared and actually FOIL it out, which is going to give me 64 minus 16a plus a squared. Okay, so once you FOIL it out, 8 times 8 is 64, negative a times 8 is negative 8 times 2. There you go. Okay, and then of course, again, I'm going to simplify it because I have here 2a squared minus 16a plus 64. So I'm just going to rewrite it there. Okay, which is going to make my derivative so much easier to take, because that's the next thing I'm going to do, is I'm going to take the derivative. So c prime. And again, I'm going to use an equation for the square root, and I'm going to write it over here. The derivative of the square root of u, so the chain rule is du over 2 square root of u. Okay? I'm going to use this to take the derivative of what I have currently. Okay? So the derivative of the inside on top, which is 4a minus 16 over 2 square root of 2a squared minus 16a plus 64. Okay? Now, we set it equal to 0. The zeros are going to come from my numerator. Okay? So all I have to worry about is setting 4a minus 16 equal to 0. which means 4a equals 16, which means a equals 4. So that means my a distance is 4. So that's part of my length. Now I need to find b. So b, I'm going to use this. So b equals 8 minus 4. So b equals 4 as well. So now that I know a and b, I can use that here to find c. So that means that c equals the square root of 4 squared plus 4 squared, which is the square root of 32. There you go. Again, this one, the math isn't really hard. The hardest part about this problem is, of course, setting up your original equations and knowing how to do that.